Hello everyone, welcome to OOkul. I am Shantanu Sir and today again I am starting with this topic of theories of machines. Okay, again we are continuing with this simple mechanisms part 3. तो आगे बढ़ने से पहले अगर आपने अभी तक हमारे चैनल को सब्सक्राइब नहीं किया है तो प्लीज इसको जल्दी से सब्सक्राइब कर लीजिए, बेल आइकन प्रेस कर लीजिए सो दैट आपको हमारे नए वीडियोस की नोटिफिकेशन टाइम टू टाइम मिल सके. ओके, और ऑल्सो हमें अपने कमेंट्स, अपने फीडबैक्स आप बताते रहिए सो दैट कि अगर हमें कहीं पर इंप्रूवमेंट का इसको कोई स्कोप हो तो वो हम जरूर कर सके. ओके, सो लेट अस स्टार्ट विद दिस. Okay, in the previous class we have seen about the concept of degrees of freedom and the Grubler equation, and from there we came to know that the minimum number of links that are required for the motion to be possible, that is for a constrained motion to be possible with the lower pairs, is 4. Okay, so from there only came the concept of the 4-bar mechanism. Okay, so simple mechanism which consists of 4 links connected by 4 turning pairs. So these are 4 links, 1, 2, 3, 4, one of them is fixed. Okay, and these are the 4 turning pairs, or you can say the 4 binary joints. Okay, so from this you see fixed position is the best position as it controls both input and output link. Please remember this thing, that is fixed position is the best position, and if your input and output links undergo complete rotation तो उसको बोला जाता है crank, then it will be called as a crank. Okay, or if it undergoes partial rotation it will be called as a rocker or a lever. Clear? तो उसको बोला जाएगा रॉकर या लिवर. नेक्स्ट हम देख लेते हैं व्हाट आर द इन्वर्जन्स. क्या होते हैं इन्वर्जन्स? व्हेन डिफरेंट लिंक्स आर फिक्स्ड देन वी ऑब्टेन डिफरेंट मैकेनिज्म्स एंड दीज डिफरेंट मैकेनिज्म्स आर कॉल्ड एज इन्वर्जन्स. ओके, जब हम अलग अलग लिंक को 1 2 3 4 हमारे पास 4 लिंक है, उनमें से एक एक करके हम जब भी किसी लिंक को फिक्स करते जाएंगे तो वी विल गेट द डिफरेंट मैकेनिज्म्स. ओके, अगर इफ योर नंबर ऑफ लिंक्स आर L then number of inversions will be less than or equal to L. Okay, so let us see the inversions of a 4-bar mechanism. The number of links are 4. Okay, so inversions will be less than equal to 4. अब ये क्या क्या है देख लीजिए, डबल क्रैंक, क्रैंक रॉकर और डबल रॉकर. अब ये क्रैंक रॉकर के बीच में मैंने डबल साइडेड एरो लगाया है क्योंकि इफ योर इनपुट इज अ क्रैंक, okay, then output will be a rocker. If input is a rocker then output will be a crank. तो कैसे पता चलेगा? How we will come to know that कि which mechanism we are obtaining or which inversion we are obtaining? Let us see that. For that we have known as what is known as a Grashof's law. What is that Grashof law? It says for the continuous relative motion between the number of links in a 4-bar mechanism, the summation of shortest and longest length should not be greater than the summation of the other 2 links. Okay, so if we have this S as the shortest link, L as the longest link, so the summation of shortest and longest should not be greater than that means it must be less than or equal to the length of other 2 links. Okay, so this is the condition for the continuous relative motion. Okay, we have already seen that is the fixed position is the best position for rotation, and we can say that best link for rotation is your shortest link. Shortest link is best for your rotation. Clear? Now case 1, we come to case 1. It says when summation of lengths of shortest and longest links is lesser than the summation of lengths of the other 2 links. Yes, that is S plus L is less than equal to, is less than, not equal to, less than P plus Q. So Grashof's law is satisfied? Yes, absolutely satisfied. So in this, if we fix the shortest link, we get a double crank mechanism. Please remember this. Okay, if your shortest link is adjacent to your fixed link, we get a crank rocker mechanism. Okay, and if your shortest link is made the coupler or coupling rod, or you can say it is opposite to fixed, then it becomes a double rocker mechanism. Clear? Double crank, shortest is fixed, shortest is adjacent to fixed, it's a crank rocker. If shortest is made the coupler or the coupling rod, it becomes a double rocker. Clear? Next, see case 2. When summation of lengths of the shortest and longest links is equal to the summation of lengths of the other 2 links, that means S plus L is equal to P plus Q, but still the Grashof's law is satisfied? Yes. Now in this also we come across 2 cases. The first one is not having the pair of equal links. In this 3 6 5 4, so shortest is this, longest is this is S plus L. 3 plus 6 is 9 and 5 plus 4, that is again equal to 9. So this condition is satisfied, but we have all the links having different lengths. So in this case all the inversions will be same as in the previous case. Okay, that means the shortest is fixed, it will become a double crank. Shortest is adjacent to fixed, it will become a crank rocker. Shortest is opposite to fixed, or it has made a coupler or a coupling rod, so it will be a double rocker mechanism. Okay, now in this case, in this only we come with one more case, that is having pair of equal links, that is 3 3 and 5 5. Okay, so in this Now comes one more case. If your similar links are opposite to each other, then it becomes a parallelogram linkage. Okay, suppose if these are this way, this is one link. Okay, so this length is having L and this is having S. So when they are opposite to each other, it becomes your parallelogram linkage. Okay, in this, either you fix the shortest link or you fix the longest link. Okay, it is irrespective of which link you fix, we will always get our double crank mechanism. Please remember this. That's why your parallelogram linkage is also known as your golden chain of 4-bar mechanism. It's known as a golden chain of 4-bar mechanism. Please remember this. Okay, it is known as a golden chain of 4-bar mechanism. Why? Because it is irrespective of which link is fixed, either shortest or longest, we will always get a double crank mechanism. Okay, next is, if similar links are adjacent to each other, then it is called as a deltoid linkage. In this, suppose this is longest, then we have this as shortest and this as shortest. Okay, this is S, L and L. So in this, if this is the case, that is the shortest or the longest are adjacent. Okay, then we will get the deltoid linkage. In this, if the shortest is fixed, then we get a double crank. If longest is fixed, then we will get a crank rocker. Because if this longest is fixed, then this shortest becomes adjacent to fixed. So it becomes a crank rocker mechanism. Okay. And the third case, when the summation of lengths of shortest and longest link is more than the summation of lengths of the other two links, that is S plus L is greater than P plus Q, then your Grashof's law is not satisfied. In this case, in all the arrangements, whether your shortest is fixed, shortest is adjacent to fixed, shortest is made the coupler, in all the mechanisms, in all the cases, in all the inversions, we get the same mechanism, that is your double rocker. Okay, please remember this. Now we see some practical examples of a 4-bar mechanism. Okay, so this is your 4-bar mechanism. It is a beam engine mechanism. Okay, this is the 4 bars, that is 4 links, that is 1, 2, 3 and 4. Okay, so 1 is fixed, this whole body is a fixed one. Okay, so we have this link 2 and we have this link 3 and this is 4. Okay, so let us see it through a help of this video. Let us try to understand it with the help of this video. What does it shows? Okay, see this. What is happening here? You can see this. Okay, so this is this link. Okay, this is your crank rotating. Okay, you can see that this is your link 2. Okay, this coupler, this connecting rod is your link 3 here. Okay, this connecting rod is your link 3. This upper portion is whole your link 4. This is your link 4. This is link 3. This connecting rod is your link 2. Okay, and this fixed link, this whole and this whole is your link 1. Okay, so just you can see that this is undergoing. In this, your shortest is adjacent to the fix. Yes, this 2 link, that is the crank, is the shortest. It's adjacent to fix. So it becomes a crank rocker mechanism. Here you can see this 2 link is rotating completely, whereas this 4 link is just doing a oscillatory motion about this. Okay, so it is not going under complete rotation, but it is undergoing partial rotation. So it becomes a crank rocker mechanism. Okay, see. Just let us see it once again. See this. Very carefully have a look at this. See how this link 2 is undergoing complete rotation, whereas 4 is just doing the oscillation about the fixed link. Okay, so I hope this is very clear to you. Okay, now let us move ahead. Another example is your coupling rod of locomotive. Okay, this is the coupling rod of a locomotive. This is the driving wheel. This is the trailing wheel. So it becomes a parallelogram linkage. Okay, in all the arrangements, you know, for a parallelogram linkage, we get a double crank mechanism. So let us try to understand it with the help of this video again. See this. Have a look at this very carefully. Okay, very carefully have a look at this. How both this link and this link are undergoing complete rotation. See, you can yourself make out. So this is the coupling rod of a locomotive and this is your double crank mechanism. Okay, it's a double crank mechanism. Got it? So this is all for today. I hope you understood about the different types of inversions or the mechanisms of the 4-bar mechanism, correct? Okay, what are the criteria? That is the Grashof law, how we obtain the double crank mechanism, how we obtain the double rocker mechanism, how we obtain the crank rocker mechanism. Okay, I hope this is very much clear to you. So in the next class, in the next video, we will be covering the inversions of your single slider crank mechanism. Okay, now in this we have the 4-bar mechanism in which there were 4 links connected by 4 turning pairs. We will see what the modification we did in converting this simple 4-bar mechanism to a single slider crank mechanism. Okay, so stay tuned for that video. Till then, like this video, share this video with your friends, colleagues, so that they can also get benefit out of it. Okay, so hope to see you soon in the next video, and till then, if you have any queries, any comments, write us in the comment section below. Also, give us your feedback through our Facebook page, Twitter page, Telegram channel, email and website. All the links have been provided in the description below. Okay, so stay tuned for next one. Thank you and have a nice day.